the one thing I did notice there is there's one gentleman, we'll call him that, that likes to argue with everything. So it's Big Bald Globe. And he likes to get on and comment, and he has criticized me as being completely ignorant, idiot kind of thing, that I don't do any research, I don't do anything like that. So he's commenting about Xavier Pascal's orbital mechanics, sitting there showing it. Well, most people would look at the official documents from NASA, which I have if nobody else has read them, on how the orbit is, and basically, I guess he Googled it or whatever and downloaded and repeated the same thing. This is how it's supposed to work, and what's the problem with that? If you're not an aerospace mechanic or engineer or anything else like that, if you don't have a pilot's license, you wouldn't understand the need to balance the center of weight in the vehicle and how that will affect the way it's positioned when you're in space. Okay, like if you're flying an airplane and you load it wrong, right? I can tell you from boating experience, if you put everybody on one side of the boat, it's going to tilt like that when you're running down the water.
Yeah, even look at on an A380, sometimes they have to move somebody that weighs 370 pounds to one side of the craft or to the back. The datum line on the craft, every airplane has one, and then you measure back from that datum. And if you do the calculations for the weight and balance, and this guy is overweight, it's going to be difficult to trim the plane.
Like if I'm reading the PDF file for whatever the official statements are from NASA on the orbital mechanics of the CSM orbiting the moon, and I don't realize the aspects of this weight distribution in the craft, but Xavier Pascal did. So then he, based on his knowledge and understanding of that balance that has to be in the craft, he then described and gave diagrams on how the craft would be positioned to do that orbit. And that's what he did, right? So this Big Bald Globe guy comes back and he reads the same, he Googles it and reads it and said, well, this is what NASA says. Well, yeah, I've read that as well. But I've also read the PDF files on mapping of the moon, because one document from NASA is a complete objectivity imbalance from any other one, because when you read the mapping one, the camera has to be pointed at the lunar surface all the time. But even Big Bald Globe comes out and he said, well, it's in barbecue mode, it's rotating. I think it was designed to rotate at 10 times per hour, so every 6 minutes it does a rotation. So if you have it orbiting once an hour around the moon, you're only going to get 10 photographs, because that's the only time the camera is going to be in position. One PDF file says it's in barbecue mode, and the other PDF file says it's mapping the lunar surface. So which is it? And this is where Big Bald Globe doesn't understand. The comment he made back shows that he doesn't have the understanding, or he hasn't done enough research to understand why we are talking about the differences in conflict. You see, Xavier Pascal looked up the dimensions, specifications, weight distribution of the CSM and said, okay, it's got orbit in this position because of that. And that's also part of a PDF file from NASA. So that one's in conflict with their orbiting mechanics that they showing it rotating, which is in conflict with the PDF file showing the lunar mapping. All three documents conflict each other. And that's the part we're trying to show. And that's why NASA has to keep updating their files. And I don't know how they can do all of that. They can't put those three together and make a new file and say, this is how it worked.
Yeah, because we got the evidence that they didn't do that.
That's right. That's right. And these guys are coming back to trying to defend NASA using one document. And then again, you take it one step farther and go to the photographs, and now the CSM is pointing the other direction up from what Xavier Pascal says, right? And it's lower than the LEM, which never happened.
Well, explain that, Mr. Know-it-all NASA supporter person.
Yeah, so the photographs, you've got at least 3 PDF files that are in direct conflict of each other. And then the photographs don't match any of that.
No.
Right?
Well, the photographs weren't taken on the moon anyway. They were taken here on Earth.
Well, if it's in barbecue mode rotating, then the only way you're going to get that lunar mapping is off their plaster molds with their little train track running across and their camera there. That's how they developed those.
NASA had found out quite early on that sending humans to the moon was something that they didn't want to risk, because they didn't want to have dead astronauts in their craft. So they thought it was much easier if the astronauts stayed here on Earth, and they made up a lovely story about what they were doing in space, which is easy to do with an unmanned craft.
I think the biggest thing is if you haven't been there, if you haven't done it, if you haven't experienced it, all you're doing is you're taking the imagination on how it's going to work and putting it into documentation. And that's not just in the documentation, that's in the statements from the astronauts when they're being interviewed, because they never referred themselves in the first person when they were talking. That's been well dissected on their...
It becomes quite obvious that the astronauts weren't there to describe what they were seeing, because they're so vague. If you were actually there in the spacecraft or on the lunar surface, you would describe it completely differently. It's almost like they're reading off a script or reading off a description or told this is what you will see. And so they desperately try to do it, but they weren't very good at lying. Maybe very good at saying things and repeating NASA's talking points, because they had to protect themselves, their families, and their pensions. They weren't going to go against what their president has said.
Well, they weren't very well debriefed because they weren't consistent in their statements between each other. Like, first you see stars, then you don't. I mean, if you were in the spacecraft, if three people are in the spacecraft and they're looking out the window, they're going to be seeing the same thing. There would be no indiscretion on what they were able to see.
No, you're quite right. But that's not the way it comes out, is it? They describe it as if they are talking in the third person about an event that hasn't happened to them. And now we know, I mean, the lead article in the current issue of Nexus has the story of why they were in that position. When you know that Neil Armstrong and Buzz Aldrin were present at the Cannon Air Force Base reconstruction of the landing, you can see what they're describing. It's extraordinary.
Exactly. And then if you take and you're looking at the PDF files that were created, those would be separate teams of people preparing them, and they wouldn't necessarily coordinate against each other. So the person that's putting all the specifications and everything in of the CSM, the fuel capacities, the weights, the everything else, and that distribution of it and the whole design of it, that's one team of people working. The other guys over there, they're going to do the orbital mechanics, and they're going to write a PDF file on it, right? And the other guys there, they're going to say, well, here's how the photographs are done, and they're doing the PDF file for the lunar mapping, right? And they didn't coordinate together and say, hey, what do you mean it's in barbecue mode? It can't be. They're doing lunar mapping. You can't have it. You can't put that in your document, right? And then the other guy's going, oh, you got it orbiting on that plane so the camera can work? Well, no, it's going to be nose down the whole time because of the weight distribution. They did it in a hurry, considering the timeline that they had to do it in. They never had any physical capability to do it and see that it actually works. You take the best scientific minds and you put it together and say, okay, it's going to react like this. Just don't forget, they never landed on anything before they so-called landed on the moon in that craft.
Well, that's not difficult. You just look at a few sci-fi films and see what happened there and create a script that describes it. That's all they did.
Yeah, they just called Leonard Nimoy and he did the calculations for them really quick.
Yeah. Don't forget that there's 400,000 people who worked on the Apollo program. You know, aside from the fact that a few were canteen workers and cafeteria workers and truck drivers, secretaries, support staff, a few of them were scientists, but there were 400,000 of them spread right across America, from Boeing up in Seattle to the Manned Space Center, now called the Johnson Space Center in Texas. It's a long way from Texas to Seattle. Then up to Florida for the launch site. Then up to New York for Grumman and the creation of the lander. An extraordinary spread of locations. Every state got funded. Yeah, they did.
Right.
That's the whole point of it. They spread it around. But that, of course, meant that because that was before the days of online communication, they had to do it by fax. Remember fax? Faxes? Little sort of buzzing noises. And US Post, they had to do it the hard way. So, of course, they dropped a few balls. They got a few things wrong. They didn't get the coordination that they were hoping for. But the central command for the Apollo simulation project didn't catch all the balls because they didn't know enough to be able to get it correct. And the scientists who were working on it, all these 400,000 people working on it, a few of them got it wrong. Or quite a lot of them got it wrong, actually. And now we've identified many of the problems. They're desperate to try and stop us going on about it. But enough people are now looking at it and saying, oh, I think some of these guys, they're right. Let's have a look at what else they've said. We've got a few hundred hours of videos for you to watch. Also look at the AULIS website, aulis.com. Look at there. You'll see some very good write-ups there from Russian scientists, Russian filmmakers, who now they can examine the Apollo record, are raising serious questions about it. Because these guys know about space travel. Hence, that was the whole space race. It was because Soviets, as they were then, the Russians, knew enough about space to be able to do it. And now we're starting to hear that maybe Gagarin wasn't the first human to orbit the Earth. Maybe it was Vladimir Ilyushin, who was launched before Gagarin, but crashed in China. Well, they're not going to talk about that, are they? Vladimir Ilyushin is the son of the aircraft designer. He was the obvious choice for the first Russian in space. He was a very well experienced pilot. He was a test pilot. He knew about piloting craft. If your retro rockets don't fire in time and you overshoot your landing site in Kazakhstan and you come down in China hard, it almost killed him. Took 6 months to recover in hospital, and then he went back to Russia. But you don't hear much about that, do you? And then there's the mystery of Gagarin. Now, what was he doing in an aircraft with a trainer? He was supposed to be an experienced pilot. He wasn't. He was just a pretty-faced little boy. He was the person who could attract attention for his alleged belief that maybe he had been in orbit, but he wasn't the first. This is the point. Now all this is coming out, and the whole thing is falling apart, and we're all now getting much more well-educated on what really happened. You know, like you've done, Scott, you've looked at all these documents. You know enough to know what the reality is. The reality is that the whole thing was a desperate attempt by America to appear to be successful. And in many parts they succeeded, because a lot of people still believe that America have landed humans on the moon. Fortunately, the younger generation now, in 2023, are less persuaded by propaganda because they have the skills to be able to identify what's going on. And many of them now say, no, nobody's landed on the moon. If it was so easy to do it, how come they're desperately trying to get back? So come on now, so you've got a bit of a problem here. It's called credibility. You've got to achieve a bit of credibility. So launch that Artemis rocket, Artemis 2 now. We've had Artemis 1, well, that was a bit of a damp squib. Now you've managed to fix the launch site, and you've fixed the launch tower, which got damaged very badly with the launch of the first Artemis, in the same way that Elon Musk damaged his launch pad, spent 3 months rebuilding it. He's now putting in a metal plate below the rocket to deflect the force of the engines, all 30 of them. Well, good luck getting those to work together. So it goes on. I mean, because we know enough to know what's actually happened and why it has happened and what should happen when we're told something has happened, and we found that it didn't work the way we were told, we say, well, what's going on? Come on, let's get the truth, NASA.
It's funny how they spend so much time to indoctrinate the younger generation from a very early age in public schools and stuff like that. And that generation still doesn't believe them. If you can't put it to them and convince them at that age, how are you going to convince them as an adult that you've done anything? Anybody that's objecting to us, it's like how to identify conspiracy theorists. First of all, don't believe anything they say, and they tell us they're this. They tell the students that they're uneducated, that they're this, that, and the other. But if you go to the ALTA site and you look at the number of people writing articles that have degrees in the topic that they are discussing, it's just amazing. I know you wanted to talk about anti-gravity there.
Oh, yeah. This is all based on a very simple premise. If chemical rockets have reached the limit of their ability, which they have, what would replace them? Because there has to be a new form of propulsion. This goes back 20 years in NASA. One of the NASA administrators, he said, the two major objectives of my term as administrator of NASA is to ensure new forms of propulsion and the protection of astronauts from the dangers of radiation. Didn't they do that on Apollo? No, obviously not. So what are the new forms of propulsion? What will replace the chemical rockets, the liquid hydrogen, liquid oxygen, liquid methane, all the stuff that's now used that makes a great show when it takes off because it's clouds of steam, huge amount of noise, very photogenic thing is a rocket taking off. But there are limits to what those rockets can do, like how fast they can go. They have to achieve a speed to overcome Earth's gravity. Now, in order to do that, they have to accelerate the rocket and all that it's carrying, which is quite a lot, to at least 25,000 miles an hour to achieve escape velocity. Trouble is that when you come back to Earth from space, you're coming back at the same speed because you're being pulled in by gravity, 25,000 miles an hour, hence the problem of re-entry. We'll leave that for another time, I think. So what are the other forms of propulsion that can be used? One of the most promising at the moment, and one that I think is being developed, if you've ever heard of the X-37B spacecraft, which is basically a small version of the space shuttle, unmanned, and its missions last anything up to 700 days, nearly 2 years it's in orbit. Well, it's somewhere. Nobody knows actually where it goes. And that has a strange arrangement on the back of the craft. It has a regular nozzle for standard propulsion using liquid chemicals. It also has another nozzle. Now that would appear to be to do with ion propulsion. That's ION, ion propulsion, which is primarily nuclear. And that may be one of the testing that is being done with it, because nuclear power is a very useful form of energy generation. It can be done from quite small fuel components, and the way that the gases are ejected from the craft can accelerate it, maybe not quite as fast as some of the chemical rockets go, not quite so fast acceleration, but it can achieve ion propulsion, can achieve much greater speeds eventually.
This guy says he's made a new anti-gravity device. There's no fans in here, like there's no props or no blades. It's not air. So you could see the grass isn't moving.
Oh, right. Yeah, that's good. I like that.
See? This is some new machine that this guy has come up with, right?
Very good.
Scott sent me some links to anti-gravity, and then I remembered this guy. I seen this maybe 6 months ago, and I'm going, geez, there's no strings, there's nothing on it. And then he goes back to a power supply or something that he has that wire's connected to.
Why is he wearing a helmet? I think maybe there's some ionization going on there that he wants to protect his eyes from or something, right?
Has he explained how it works?
Two counter-rotating discs that are charged with a high voltage apparatus.
Right. Well, he's basically, the article in ALICE is describing that same effect with fast-moving rotating particles, right?
The only difference is he's charging these discs with some oscillating high voltage. Like there's a frequency, there's a high voltage frequency that's pelting those spinning discs.
Yeah. Like I said, where's the weight penalty to get the amount of power to lift an actual spacecraft?
This almost reminds me a bit of what Lazar said with capacitor plates.
The vehicle he's showing it might be able to do that. But if you take and you put the power where the power source is coming from on board the craft, the weight penalty of that is going to be the problem, especially if you're trying to lift the spacecraft. Your weight penalty probably exceeds what current fueled rocket engines are, the weight penalty you get to provide the fuel.
This is interesting when you watch it take off. This is the first time I've ever seen anything like this in my life.
Which just shows it can be done.
Yes. Yeah.
There are people working on it. I mean, there have been people working on this sort of stuff for many years. In the early 1950s, there was a lot of discussion about anti-gravity work. And then suddenly it all went black. It was all taken out of the discussion. Somebody who does discuss this, not in detail, but describing what is going on, is an Australian guy called Stan Deo. I don't know if you've ever seen any of the films he's produced. He talks about this as well.
Well, I would love to see these frequencies this guy is using. Of course, he won't tell you, but the plates, what are they made out of? What are those two counter-rotating plates made out of, I wonder? Because you can see them spinning. They're right here. See them? There's two of them, one here, one there, and you can see them spinning in there.
And it sort of moves in the way that a lot of people describe UFO moving, sort of a feather in the wind.
Yeah. I find it interesting that when he pushes it down, how it reacts. Like it doesn't just tip over and flop around sloppily.
It'll have a gyroscopic effect if the discs are spinning fast enough, right?
But sometimes a gyroscope, if they go too fast, it will actually, if you tilt the craft, it will just go like this and flip. So he's got to have these spinning at the right speed as well. If that had a power supply on board and was flying around inside of a field, you'd think that that would be a UFO the way it just...
Is the power supply that it might not be able to lift. He's got the wire coming up to just a certain height, and then he's got it secured to the ground because it would lift the wire higher than that.
It just amazes me how that thing behaves just like a flying saucer.
Yeah, well, that's the whole thing is how much power does it take? Because it does not have the power, like if the power source was, like if you put a couple of Hasselblad Varda batteries on there, would a couple of those work and would it be able to lift the weight of the batteries? That's the whole point. The power source is independent of the vehicle. And there again, you're back to the weight penalty of rocket fuel, reducing your payload down, right? Or negating it completely.
Very interesting. It's just because I've never seen something actually function like this.
The one thing I can say, though, is if you have a device like what we were just looking at, and it has some benefit, let's say it won't lift a vehicle, but let's say it reduces the weight of the vehicle by half. What would that do to air transport? Now you can carry twice as much. A vehicle could be very large and land on a very short landing strip because you've reduced the weight so much to the wingspan you've got available. If you have a device to do that, you could put it into construction of buildings. You could put that device on there and reduce the weight of it that you're actually lifting and set it up, and the crane puts it in place, right? Many applications, even if it's not practical for space travel, if you have an anti-gravity device that you can provide like that, like think about it on the ground, and you need a large power source to run it. Well, you're not then lifting the power source, you're only providing the power to it. And you could take large, heavy materials and lift them into place by reducing the weight.
This kind of technology will never see the light of day. You know it, and I know it.
I know, but I'm saying if it's available, if it doesn't work practically for space travel, if it isn't capable of lifting that kind of stuff, but if it actually works to reduce the weight, if it does provide some lift on it, it could be used in many commercial applications.
It's quite right. It could be. Very useful too.
Yeah, very useful. You think about it in construction.
Then we come back to the perennial question. Well, how did they build the pyramids? You know, the Great Pyramid of Giza, 481 foot high.
Oh, there's an application right there, right? How many million stones are there in that thing?
Well, they say it's 2.5 million.
Yeah.
I reckon it's more. I reckon it's nearly 6. But the point is, it's the lifting of the 70-ton blocks of granite which roof the King's Chamber 300 foot above the ground. How did they get them there? And don't talk about pulling them up ramps, because that's such a stupid idea as to be not even worth discussing, so we won't.
Those stones, the granite stones, are what, close to 100 ton?
About 70 tons each.
The biggest equipment that we have right now is around 22 tons that we can lift.
Yes, but we don't have hundreds of thousands of workers.
And they didn't have hundreds of thousands of workers then either. They had some dedicated engineers. We call them engineers today. I don't know what they called them back then, probably priests, because they could do magic things. But they were still able to lift 45 70-ton blocks of granite, which had been transported 500 miles from Aswan to Giza, lifted them 300 foot into the air. And don't forget, it's not just a straight lift. You've got to you lift them off the ground, and then you've got to move it across to the center of the pyramid before you can put them on. We don't have cranes that can do that today.
Not to mention they were set in place with absolute precision that you couldn't put a piece of paper between them.
That's right. Yeah. Extraordinary. Absolutely extraordinary. Nobody's explained it properly. People have tried to.
I don't think they ever will.
No.
But you know, when you see people that have tried this on YouTube, they take discs and they rotate them and they do this and that. And I mean, all they do is shatter. So the whole device just shatters apart.
Yeah.
You know, I mean, putting 2 discs and rotating them opposite directions isn't going to make anything fly without doing something to it.
Well,
you know?
if it's producing an electromagnetic field.
But the question is, what is this thing doing?
Well, that's not described on what that particular device is doing. But if you create an electromagnetic field, you're also creating a magnetic field at the same time. Like the reason why it's stable, just any spinning device, you're creating a gyro at the same time. That's what's stabilizing it. But the lift capabilities of what anything you read at electromagnetic plasma fields and stuff like that create lift. And that's proven in small quantities in laboratories that they've demonstrated that, right?
Yeah, but they've always had to have an external source.
That guy's using an external force providing the hydro to it, right? He's not lifting the energy source that's providing the energy source there. He's only lifting just the discs themselves on that.
Yeah, but the batteries, now you have to think about it, because now you need the power source, which would be batteries or LiPo batteries, and then that would have to be converted into AC, and then that would have to be converted into the frequency, and then that would have to feed back again.
Well, like I said, that little video you put up there, the weight penalty's not there because the power source is not on board the vehicle. And that's the same thing as when they're doing it in a laboratory, the power source is external from whatever they're designing. And that's what I'm saying is if they develop it further, it could be used probably better commercially, because you could have a remote power source on a construction site powering it and using this to assist in a lift, to reduce the weight of something, to make it much safer for things to work on, to keep large cranes from having accidents when being blown around, right? You can lift a lot of that percentage of weight off when you're lifting things into place. But the power source is still going to be remote from that, maximizing your lift capabilities. The demonstration, if you're looking at a space vehicle, you have to overcome all of that and have an energy source that is continuous all the time. So it's a very, very large energy source. And will that lift the vehicle off the ground with the full weight of it on there? And that's the same problem you have with rocket engines right now. The fuel is the penalty all the time. If you want to build a bigger, more powerful engine, you eventually get to the point where there is no payload left. The amount of fuel you're burning to the size of your rocket engine, you put more fuel on it and it can't even lift the fuel.
But you see, the thing is that until they come up with something better than a rocket and more efficient than a rocket, these people are going nowhere.
That's right. You are limited in the capabilities it's doing. Even Elon Musk says getting something to space is one thing, but it's 1,000 times harder to get something into orbit.